Hello everyone, in this video we're going to be solving a fantastic geometry puzzle. Two circles with radii 1 and 2 are tangent to each other and to the axes as shown. An equilateral triangle is inscribed in the region between the circles and the x-axis. Find the side length of the triangle. So at this point you can just go ahead and pause and try the problem yourself first. Okay, let's get started. So we're going to be making some connections as always. Okay, let's go ahead and start with the triangle here. Okay, so and then I'm going to make another connection here, this point to that point. Okay, and then I think I'm going to be dropping a perpendicular from here as well. Okay, so let's mark some length. So this is a 90-degree angle as well as this one. This is 1. We know that those are 1. And we'll also make this connection here. This is also going to be the radius. So that's going to be a 2. Okay. And coordinate-wise, the value here is going to be, the x-coordinate is going to be 2. Okay. We don't know where the triangle and the larger circle intersect, but I'm just going to need that point. So let me go ahead and drop another perpendicular here. And let's call this x-coordinate of this point x, which makes sense, right? Okay. And let's call the side length for the triangle A. So my goal is actually going to be finding A in this case. Okay? All right. Let's get started now with the solution. Now we know that this is an equilateral triangle, so this is going to be a 90-degree, I'm sorry, the 60-degree angle. And as you know, we draw two tangents from this point to the smaller circle. Therefore, this is going to be an angular bisector. So each of these needs to be 60 degrees, right? Okay, that's good. Now we know all the lengths pretty much. We have the 30, 60, 90 triangles here. So the longer leg is 1, so the smaller one, the shorter leg is going to be root 3 over 3 here and root 3 over 3 here. Okay, so that's going to be helpful because we can find the x-coordinate of this point and then just subtract root 3 over 3 from there. So let me go ahead and erase that here. And I'm just going to go ahead and write it down here. So this length is root 3 over 3. So let's go ahead and find the x-coordinate of this point first of all, right? So for that, we're just going to connect the centers of these two circles. Let's go ahead and do that now. Okay. And what happens here is if we try to find this length here between the points of tangencies, I'm going to draw a horizontal line here. Okay. That horizontal line is going to be parallel to the x-axis, right? Okay, cool. Now, we know that this is 1. So let's go ahead and erase that. So this is 1 and this is 1. What else do we know? Okay, we know that this is 2 and this is 1. So we have a right triangle whose hypotenuse is 3 and one of the legs is 1. So from Pythagorean theorem, this is going to be 2 root 2. So the x-coordinate of the smaller circle is going to be 2 plus 2 root 2. Okay, that's nice. And now I want to find the x-coordinate of this point, which is actually super important. So what I'm going to do is, actually, I don't think it's going to fit there. So what I'm going to do is I'm going to call that x sub 0, okay? And then I'm going to calculate it somewhere else. Okay. Well, it's kind of easy because we just calculated this length to be root 3 over 3. So all I have to do is subtract. So x0 is going to equal, let me go ahead and change the color here. Maybe white. Okay, awesome. So x0 is going to be 2 plus root 2 root 2 minus root 3 over 3 because we just have to back up that much, right? Okay, awesome. Let's make a common denominator here, make it nicer. It's going to be 6 plus 6 root 2 minus root 3 all over 3. Okay? All right, that's going to be my x0 value, which I'm going to need because my goal is now to be able to write the equation of this line here. Okay, what line am I talking about? Let me go ahead and show you here. This is actually the line I'm talking about. I'm talking about this line here. Okay, So I'm trying to find the equation of that line. And I know the slope of that line actually. How do I know the slope? Well, it's making a 120-degree angle with the x-axis. So its slope is actually going to be negative root 3, which is tangent 120, right? Tangent 120 degrees. And that's going to be negative root 3. Now, that equation is actually going to be important. Now, we do know the x-intercept for this line. But let's go ahead and write the equation of the line first. So the equation for the line, which has a negative slope, is going to be negative root 3x plus b, right? And to find the value of b, we're actually going to replace x with x0 and y with 0. Okay, let's go ahead and do that. Y will be 0 and x will be x0. So we're going to set x equal to x0. And the x0 value, we just calculated that right here. So that's going to be times 6 plus 6 root 2 minus root 3 all over 3 plus b. And obviously from here, if you just add this quantity to both sides, b is going to be the square root of 3 times that, which is actually going to leave us with a root 3 at the bottom, if you simplify that. So it's going to be this. But then I multiply by root 3 over root 3 again to rationalize the denominator. And the b value is going to be, if you distribute the root 3, 6 root 3 plus 6 root 6 minus 3 all over root 3 times 3, which is 3. And then you can simplify this, and b is going to equal 2 root 3 plus 2 root 6 minus 1. Now, this was our equation, right? So we're going to go ahead and plug that in. And the equation for the line is going to be negative root 3x plus 2 root 3 plus 2 root 6 minus 1. Okay, now why is the equation of this green line important? Because we're going to go ahead and find the intersection point of the line and the larger circle, okay, whose x-coordinate is x, and then we're going to find that x value, which is actually super important. Why? You're going to see in a little bit. So let's go ahead and find the x value. Now, how do you find the intersection point of a line and a circle? Well, you do need to set their equations equal to each other, right? So what is the equation for the circle? Okay, the circle has a center at 2, 2, and its radius is also 2. So the equation of the circle is x minus 2 squared plus y minus 2 squared is equal to 4. Now, to be able to find the intersection point of the circle and the line, I have to solve this system simultaneously, right? So to be able to solve the system, the only method pretty much is substitution here. Look at this. Like, you can just replace y with something, right? Let's go ahead and do that. And then we're going to end up with a single variable. So I'm going to replace y with this gigantic expression, right? Negative root 3x plus 2 root 3 plus 2 root 6 minus 1 minus 2, which is equivalent to minus 3. And that thing is squared, and the whole thing is equal to 4. So I'm just going to save you the trouble of trying to simplify this equation, because it's just going to be a quadratic, but it's kind of time consuming, you know, laborious. So what I'm going to do is I'm just going to give you the result, which is the x value. And there are two solutions here. One of them is not going to work, okay, because of size. So the valid solution to this equation is going to be x equals 8 plus 6 root 2 minus 3 root 3 plus the square root of 12 root 6 minus 17 all over 4. Okay, so that's going to be our x value. Isn't that nice? Beautiful, right? Okay, awesome. Well, if you don't trust this, you can go ahead and check it for yourself. Okay, now what I'm going to do. So I got the x value, and I was just telling you that I was going to tell you about this. So why did I need to find the x value? Well, because for an obvious reason. Now, if you check this out here, I know the x0 value, right? I just found it, and I know the x value. So by subtracting those two values, I'm actually able to find half the base, because as you know, the perpendicular line, the height, is also a median, right? Because it's equilateral. Therefore, all I have to do is now to find x0 minus x and just double it. That's all I need, right? Okay, let's go ahead and do that now. I need x0 minus x and then just double it. Okay, well, what is x0? We gotta go back to where we found it, right? If you remember, x0 was found here. And the way we found it was we subtracted root 3 over 3 from this x coordinate because we know that it's the distance between them, right? So x0 is given by that value, 6 plus 6 root 2 minus root 3 divided by 3. So what I'm going to do here is I'm just going to go ahead and multiply this gigantic value, which is x0. I'm going to go ahead and write that down. 6 plus 6 root 2 minus root 3 all over 3 minus x, which is 8 plus 6 root 2 minus 3 root 3 plus the square root of 12 root 6 minus 17, and that all over divided by 4. Now at this point you can just go ahead and make a common denominator. Let's simplify this a little bit for fun. Okay, we can make a common denominator, so obviously this is going to be multiplied by 4, but then there's going to be a 2 here. So you can think of it this way. The common denominator is going to be 12, but cross cancel with the 2, that's going to be 6. So let's just go ahead and multiply this by 4 here. That's going to give me 24 plus 24 root 2 minus 4 root 3. Now I have to negate everything, be careful. And then I'm multiplying everything by 3 here. Minus 24 minus 18 root 2 minus 9 root 3 plus 3 times the quantity square root of 12 root 6 minus 17. And the whole thing is going to be divided by 6, not 12, right? Because we cross canceled. Okay, we can simplify this a little bit more. Obviously, 24 is going to cancel out. And then we have 24 root 2 minus 18 root 2, which is 6 root 2. So I can just go ahead and write it as 6 root 2. Then I have the minus 4 root 3 minus the 9 root 3, which makes minus 13 root 3. And then finally, I have the radical expression, 3 times the quantity, 12 root 6 minus 17, square root of that, and all over 6. So that's going to be our A value, which is the side length of the triangle. Thank you for watching. I hope you enjoyed the video. Please comment, like, and subscribe, and I'll see you in the next one. Take care.